I'm Manu Shivanand. I work with the business development team of Tata Structura. We are a part of the Tata Structura team. Tata Structura basically deals with hollow sections, your piping requirements for your structural applications, for your conveyance tubes, for your boiler and other general engineering applications. Uh, Now, as you know that people who are working with hollow sections, so earlier from the RDSO gentleman had mentioned that uh, now we are trying to move into hollow sections from the earlier angles and channels that were being used. You see that this is a product which actually gives you a lot of benefits in terms of not just your strength to weight advantages, but also with respect to your aesthetics and the overall look and feel of how your structure is going to be. Uh, as you know, YST 310 is something that generally is prevalent in the market. This has now almost become like a commodity where people are using hollow sections. Tata Structura has now come up. In fact, we've been here for about the last 2 years with this high strength product, which is YST 355. I'll just take you through this in a small while. Yeah. So, like I said, hollow sections, people are actively considering today as to what are the different advantages, how is it helping you achieve different shapes and sizes, your design principles being is coming into play. Some of the segments and applications that we generally look at are, as you know, in industrial, mostly into sheds and warehousing. Pipe racks, as you know, would be, you look at all the refinery projects that are coming right now, even if it is for your IOCL or for HPCL. I was just talking to a person from EIL who mentioned that they were also initially using angles and channels, but now they've moved into hollow sections. Obviously, there is an advantage that they are seeing from using this. Infrastructure in almost all of the airports you see that hollow sections are being used. At one point of time, you knew how the Bombay International Airport used to look like with the moderately designed concrete structure. But now if you look at even the roofing that has been there in Bombay Airport, it's an entirely different marvel. People come and look at it in a different view altogether. We are proudly, we can be proud to say that yes, we've been involved in that project in addition to all the other airports that have been coming up in India. And there is a very big thrust, as you can see, with the amount of airports that are being proposed to be coming in India. Housing and commercial, again, this is a segment where we are still mostly prevalent on RCC, but there are some cases where people have moved into completely steel structures. We are hoping that this becomes a trend in the future as well. General engineering, now I know most of the people here are into the structural domain, but as you see, like, I can probably give you an example of how tractor bodies are today. You see the cabins over there, and because of the new mandate from the government of India, where people, for your cabin body, people were using normal angles and channels. But now with the rollover protection system that are coming in, with additional safety mechanisms that are coming in, the government of India has given a mandate that people should, or the design should be more stable, more safe, and hence people are now looking at hollow sections to be implemented in these applications. Like I said, airports very actively involved. Railways, I'm proud to say that under IR SDC, the new Habibganj railway station that is coming up, the first station under the PPP model, they have been a pioneer, both IRSDC and RDSO, in implementing hollow sections. The Habibganj railway stations, we've almost supplied the 100% requirement for their cover over platforms, and we'll be supplying it for their FOB designs as well. It is something that I think all of you should have a look at, because one of a kind design, and it will come out beautifully, and we are like very happy to be involved with that. Uh, Stadiums, I'm just showing you some of the applications that are there. Industrial structures, even as you know, there is a big contention between whether should we go with a PEB structure or should we go with your general conventional way. But as you look at it, for larger span structures, like for your cement sheds or for your raw material sheds, people are now looking at hollow sections rather than going for your conventional I-beams, or because they find it more economical in the case of hollow sections. And these are actual cases that we are getting from the major PEB players that are involved in the country. Housing and commercial, yes, not a big breakthrough for us, but still there are some projects that we are actively involved with, and we are hoping the architect and designer community starts implementing more of hollow sections and starts achieving much more better designs and look and feel to it. Some of the projects, you can see the spherical dome, which is the Infosys Pune office. General engineering, like I was mentioning to you earlier, a lot of new applications that are coming in. Even with your automobile sector, this is something that we didn't expect that, okay, there is an application here, but today we are seeing a lot of demand coming from a variety of OEMs asking for hollow sections. Okay, I'll just spend some time over here. So what we are trying to tell you is that by using a higher strength grade of the material, you're eventually reducing the thickness or the section sizes that you require for your design. And thereby you're achieving a more optimal design, and it is helping you move, in fact, giving you a better weight savings in this case. You look at TMT also, there was a time when people used to use 415, then it moved to 500, 550, 600. So the reason that is being done is that you achieve a sleeker look, you achieve a better design, you reduce the steel consumption, your overall project cost is coming down. A similar methodology is also what we are trying to adopt over here. See, now there's something called as reliable and consistent high quality. Now it's a very generalized term that we can actually use over here. I mean, anybody can come and tell you that it's a reliable and consistent high quality. But what we are trying to tell you is when there is a tube that is being made, now there is a process involved. There is a hot rolled coil which goes through a stage of cold forming, and then it comes and is molded into a tube. Now this is a general small brief of how tube making is done. But one very important thing which is mentioned in all the IS codes is also that, let's say you want to form a tube which has a yield strength of 310 grade or 310 MPa. It should be of utmost, it should be absolutely necessary that the raw material that you're using should also be of the same grade. Now I'll tell you why. When you do cold forming, which is the stage from where you're converting the flat HR steel into your tube, there is an increase in the yield strength that is happening. So let's say if I use a raw material of 240 MPa, when the cold forming is done, this increases to levels of 310, 320, 330, probably 340. But the next time you use this product at your site, let's say you have to fabricate it, you have to anneal it, you have to do any jointing, at that particular area, this yield strength actually comes down to its parent material's yield strength. I hope I've communicated it right. You use your parent raw material, it has a yield strength. During cold forming, this increases. While you use it at your site, this increased yield strength comes back to your parent raw materials yield strength. So had you used 240, at the end of the day, at your site, you're only getting 240 MPa. But what we ensure is now, all the material, all the raw material that we use for our tube making comes from our own plant. From all the HR, which is the primary raw material for tube making, comes from our own Jamshedpur and Kalinganagar plants, right? So we ensure that, let's say if we have to make 355, then we ensure that our HR raw material also has that particular yield strength. We could also be doing that we use 310 yield strength raw material and achieve 360 or 370. You would probably see in the test certificates also the values are as per your requirement. But that is not how it has to be done. And we also guarantee the fact that in case you want the traceability all the way up to the HR raw material, we can do that also. So that is something why we delve on the point saying that, yes, we are reliable and we consistently give you high quality. I just want to mention about one point regarding railways. So railways, as you see, like sir was mentioning, that in Delhi, corrosion might not be a problem, right? But in Bombay, corrosion is a very big problem. Now, something that I've seen with what Western Railways does is they do metallizing at the site, which involves different layers of your paints and all that. We have a galvanizing option. Now, when I say galvanizing, it again probably is slightly more expensive than your metallizing, but it is not manual at all. When you're doing metallizing, you're actually dependent on the labor that is involved over there, right? But then there is a follow-up question to that which we get from different architects and designers, structural engineers. Let's say if I have to do a jointing, let's say I have to do certain annealing or cutting over there, then what happens to the particular area where the galvanizing has been done? Doesn't this go off? So today we know of zinc sprays that can be used. Again, this is, as a raw material manufacturer, we are also trying to guide and help people use more of hollow sections, and we are trying to see what are the difficulties that they are facing. Galvanizing, like corrosion, there was a big discussion going on earlier. We've been getting a lot of queries. We are also actively working on it. Hopefully by the next time I'm here, we should be able to give you a concrete solution. But in the meantime, we would really request you to look at the option of galvanized tubes or galvanized sections, including the use of zinc sprays for trying and implementing it at your sites. What we are guaranteeing you is that at least there would be an overall saving of about 10 to 15% in your steel consumption, and thereby, yes, we have to use a more expensive raw material, so there is an additional charge involved with it. But your overall project cost actually, because of your reduced steel consumption, comes down by at least 5 to 10%. That is what we are trying to guarantee you. In circular hollow sections, like I said, with the acquisition of Bhushan Steel, we are now in a position to give you up to 600 dia circular sections, up to 21 thickness. We are one of the very few manufacturers in the world right now who can give you this. In fact, in square and rectangular hollow sections, we can go up to 16 thickness. Again, this is a very unique capability that we have in the domestic market, and with the advent of different technologies or different applications like concrete filled tubes, people are looking at using this as a proposition for your upcoming buildings and all that. We would try and suggest that use these products rather than getting it welded or fabricated at site. These are ready-made available products which you can probably use for your future projects. Green Pro is something that we are really proud of. Again, people who are there in the housing and commercial space, who wants a certification, be rest assured that our product is Green Pro certified. In fact, the only structural product that is currently Green Pro certified right now, and again, which is a big boon for you in case you want to achieve those green building certifications. Quality and testing, again, welding is, okay, people generally tell you, okay, why is it that we should use, why not use seamless tubes? Or why is it that, what is the big difference between ERW and seamless? One big query, what people, or feedback that we've generally seen is the weld that is involved. What we are trying to tell you over here is, you want the macro examination results, you want the x-rays of each and every weld of our tubes, we can give that to you. And we will ensure that it conforms to the IS codes that are there. Again, this has recently been inducted in IS 4923 and 1161. Regarding the chemistry, we ensure that sulfur is a very big component that you should be looking at. In case in the future you are going through TCs, please ensure that sulfur content is within the limits, because it is one impurity which actually affects your ductility. Here we've just tried and showed you, we're just trying and showing you what is the steel saving advantages that we are getting when you compare it between a 310 grade and a 355 grade for your tension members, for your compression members, for your flexural members. So you can see for your flexural members, we are achieving almost 15%. For your truss and purlin designs, we are achieving approximately 19%. Now, you can always come and tell me that why use a hollow section, why not just use a Z purlin? That is also a case, but here we're just trying to tell you, in case you move from a 310 grade, which is the norm right now, into a higher grade, what is the actual savings that you're getting by using a higher strength product. Like I said, 10 to 15% weight savings is what we guarantee. There is a concern that what we generally see from structural designers, let's say, okay, I've already designed something, now why should I redesign it? So Tata Steel by itself, in case, for clients especially, in case you want us to redo the design, we are more than happy to do it. We have that technical capability. We have a team in Tata Steel right now which can help you with that. Probably give you an initial cost saving or cost benefit analysis as to why using a higher grade product would benefit you. I'll just take you through two more products. I think we have the time for that. Yeah. We've come out with something called as HNI sections. The basic idea is, instead of using your rolled sections, which would be your ISMB 500, which would be your ISMBs, your UB, UCs, your narrow flange beams, we are coming with 3-plate fabricated sections. The biggest benefit or the advantage that we are trying to tell you is that customize it as per your requirement. Give us any different combination for your thicknesses, for your web and flange. Give us any particular length and we'll make it and give it to you. Thereby, it completely avoids any sort of fabrication that is required at site. Your manpower is actually coming down. The capital involved, because you have to keep that material at your site and then get it fabricated, all that comes down. This is probably, a lot of you might be aware of something called as a cut and vent steel, cut and vent rebars, in which you're not buying steel anymore. You're not investing in it. You're just telling a third-party manufacturer to get it done as per your BBS, and you're just getting it installed at your site. This is the same concept that we're trying to do over here. And what we tell you is that we can go from 300 mm depth up to 2 meters depth. Again, I've already mentioned, and be it any length, be it grades of 250, 350, 450, we can do that for you. Even if you want it in ASTM grades, that is also possible. We've again just tried and shown you what a small difference you would be getting in case you use a standard I-beam versus, so TSMB is a nomenclature that we are just using for Tata Structura medium beam. And you see that if you just look at the section weight itself, you see that we are achieving about 10% of weight savings. Again, all the sectional properties are higher than what an ISMB 600 would offer. So this is something that I think you should really explore, especially with bridge design, with all these big sections, all these big requirements coming in. This is a facility that probably people can actually look at. Like I said, what would be the different advantages? Brief look at the product. Last thing that I want to talk to you about is fire resistant steel. Now, a big problem that people or designers come and tell us when they have to design with steel is that fire resistance, which is not very good in the case of steel as compared to RCC. We've come out with a great, now if you look at the general methodologies that are adopted in the site, would either be your intumescent paints or your vermiculite paints. Now you know this is again done manually. There is a risk, see, like sir was saying, there could be just a 0.5 mm gap, but that is enough for actually exploding later or probably causing the entire damage. What we are trying to do here is we are inherently changing the steel chemistry. Thereby, there is no manual intervention involved at your site. The product that you're getting by itself is fire resistant. And we've completed tests at IIT Roorkee. We've also made some trial supplies in the southern and western markets. And again, at a price point which is much more competitive compared to your intumescent paints, and also the fact that you don't have to be reliant on manual labor for this. And it is as per the IS codal requirements, which states that it has to It has to maintain at least 2/3 of its yield strength, even at the end of 2 hours of fire exposure at 600 degrees. So that is what we are guaranteeing you. Again, we don't have an NBCC license or a BAIS license for it, because currently we believe we are the only manufacturers in India today for this. But with your help, we would like to try and implement the project. Again, I know there could be a lot of inertia because it is something which relates to fire, but with the right tests, with the right results, and with the right conclusions, I hope this can be a product that you people can actually explore. And yeah, that's about